Good evening, all of you. We will start the meeting within 5 minutes. Let's wait. People will join. Okay, so let's start the meeting. Here we will discuss seventh assignment on nature and properties of material. So let's see the first question. Which of the following polymer has a random arrangement of side groups? So these are the four option: atactic, isotactic, symbiotic, and cotactic polymer. So let's see. Answer will be a tactic polymer. Here is the concept of the placement of the side group, which is known as a particular name, atactic, isotactic, symbiotic. So atactic means a random placement of side group. Let's say CH bond, C carbon bond, Cl vinyl side group. So based on their placement of the side group, these side groups known as atactic, isotactic, and geotactic. If the side group being placed the same side known as isotactic, if the regular alternating arrangement of the back and front like here is known as seniotactic. So let's move on the second question. Which of the following polymer has a regular alternating arrangement of the side group? As we discussed, now please answer the question. So based on the previous question, as we know, this is known as if the alternating of the side group is syndiotactic will be the polymer, and if the same side, the, the side being closed is known as also isotactic. Next question, the repeat unit in the nylon are linked together by. These are the four options. Please choose the right option. First is aldehyde group, amide group, hydro hydroxyl group, or amine group. Yes, please. So answer will be amide group. Let's see. Nylon structure is a polyamide group, CONH, is known as a amide group, which is linked together hydrogen through the hydrogen bonding. So let's see elastomer. Elastomer demonstrate rubber-like elastic behavior. and long chains molecule with the same degree of the cross-linking mobile portion, that will be the few hundred of the nanomers, excellent bonding and recoiling properties. As natural rubber is also isopropene molecule. You can see in the picture vulcanization treatment with the sulfur. So the vulcanization of the rubber take place by the its treatment with the bromine, phosphorus, chlorine or sulfur. As we discuss, answer will be the sulfur. Okay. Next question. Which of the following is are correct for the polymers? These are the options. Thermosets, polymers soften upon heating, vulcanization, rubber, epoxies, and phenols belonging in the same class of the thermosets. Cross-linking is the characteristics of the thermoplastic polymer. Thermoplastic polymer have a linear and branches structures. So answer will be B and D. Thermosets, vulcanized, okay, rubber epoxy or resins and bakelite, and polymer thermoplaster and thermosets. Okay, so let's see the next question. XRD is let's we will discuss basically on this. First part is based on the polymer. Now let's move on the XRD parts. So this is the primary characterization of the material XRD, which is identified to determine as like we first question. XRD is primarily used to determine electrical conductivity, crystal structure and phase identification, band gap of the semiconductor, magnetic moment. XRD is used for crystal structure and phase identification. Answer is D. How we can determine the crystal structure and phase identification, we will see. And next question, let's see. X-ray are most suitable for the diffraction studies because their wavelength is the order of. Why is X-ray suitable for diffraction studies? And for that, order of the wavelength will be 10 to the power minus 12, 10 to the power minus 10 in meter, 10 to the power minus 6 in meter, 10 to the power minus 3 in meter. What would be the wavelength most studied for diffraction pattern? You know, so we know X-ray is like most studies X-ray will be lying 10 to the power minus 10 meter range because it is comparable with the interatomic spacing in the crystal. That's why we are using. For that, if we are using X-ray diffraction, Braggs law is given by which option will be the correct option? N lambda equal to 2 theta, n lambda equal to d sine theta, n lambda equal to 2d cos theta, lambda equal to 2d by sine theta. Yes, please give me the answer for the Braggs law. So for Bragg's law, we know 2D equal to 2D sin theta equal to n lambda. This is the law. For that, the first order diffraction is observed when A equal A, B, C, D. Which option is correct according to the Bragg's law? Use n equal to 1 and give me the answer. So we know 2D sin theta equal to n lambda. You can put n equal to 1 for that. So 2D sin theta equal to lambda. First order, which is known as first order diffraction. Okay, let's see the next question. Powder XRD, PXRD, is used mainly for measure sense resistivity, identify polycrystalline phase, measuring magnetization, measuring thermal conductivity. So we know XRD is basically used for identify the phases. For powder, this is polycrystallized. See the next question. The intensity of the XRD peak dependent on the only wavelength, only crystal size, atomic scattering factor, and structure factor, magnetic field. These are the options A, B, C, D. Which one is correct? So answer will be C. We know atomic scattering factor directly depend and structure factor will impact the intensity of the XRD. So see the next question. Which crystal plane usually give the strongest peak in the XRD of the cubic structure? Cubic structure 100, 110, 111, or 200 plane. Which one? Strongest peak in the XRD. So let me, if the plane has like C, highest density will give the strongest peak. You can calculate the density. So triple one plane highest atomic density. Next question for a copper K alpha radiation lambda equal to 1.54 angstrom and interplanar spacing d equal to 2 angstrom. What is the Bragg angle for the first diffraction or reflection? You can take 5 minutes for this question, but please solve this question. Here is the given for you copper K alpha lambda equal to 1.54 in angstrom and interplanar distance is already given 200 angstrom and the Bragg angle for the first order reflection you can use n equal to 1 So you can use Bragg angle 2d sine theta equal to n lambda. Use this equation, put these value in this equation and please find the theta. You can take 5 minutes for this question, but please solve. Let me know the answer. Then I will discuss. So all things are given to you. Use this first equation. This is the Bragg law. D is given, N is given, lambda is given. You have to find the theta. So let's put this all these things in equation. This 2 d equal to 2 in angstrom, sine theta equal to n equal to 1. Then let me put in angstrom sine theta equal to 1.54 divided by 4. Calculate, let's say sine theta. Let me use the calculator. 1.54 divided by 0.4, it will be 0.77. So take the inverse, sine inverse 0.77. Yes, solve this equation. Please solve this. Answer will be B. So theta will be 22.5 in degree. We get one or where is 1 minute. We have 1.54 divided by 4. Oh, sorry, we are wrong here. Now please check. This is Correct answer or not? So here is the solution we have did. Like that we can find the theta. If the information are given for the 2D equal to 2D sin theta equal to n lambda, please use this equation. We can solve one unknown from where. Got it? So let's see the next question. The transition taking place from M cell to K cell emits which of the following characteristic X-ray? K alpha, K beta, L alpha, K gamma. M cell to K cell. Electron transition, let's say this is M cell to K cell taking place. Electron. So, 1 minute. Let me show you the answer. K beta will be the X-ray known name, and here is the nomenclature based on the selection rule. K, L, M, N. This is the cells. K cell, L cell, M cell, N cell. A bit transition taken from L to K is known as alpha, is and beta. If transition taken from L to K is alpha, M to K will be beta. If N to K, then gamma. Alpha, beta, gamma. K alpha, K beta, K gamma. Then this is also possible. M to L. This is L. Why is K naming K alpha, K beta, K gamma? Because electron is come to K cell. If come to L cell, then L alpha, L beta, L gamma from first, second, and third nearest cell transition. Alpha, beta, gamma. Okay. So this is known as K beta. Why? M cell to K cell. If taking from L to K, then K alpha. But here M to K, that's why is beta. If transition taking from M to K, then gamma. Okay, please remember these things. And if the electron, how electron is, first we had like that. Incident is come and excite the, or replace, exact the electrons, and another electron come from upper level to lower cell, fill this gap and emit the X-ray again, which is detected by the detector and measure according to the position theta to theta. Then we will determine how this is the material type. One minute. Sorry. So please remember these things. Let me clear one more time. I'm yes. Okay, wait 1 minute. So let's say this is case L. If transition nearest is L, then known as alpha transition. If electron come from L to K, emits X-ray, which is detected by the detector, which is known as characteristic K alpha. Okay, if upper transition, then beta, known as K beta. Okay, similar like. So see the next question. Which of the following metal is used to filter out K beta component from the copper X-ray radiation? Nickel, molybdenum, chromium, cobalt, and why? So let's see, the answer is nickel. Nickel. Nickel has a can absorb this copper K beta radiation. So X-ray undergo the absorbance I equal to I naught exponential mu rho into rho x. Nickel has a spectrum. You can see this blue line. Let me use different color. This is for nickel, and copper has a, let's say, this is copper. Copper K alpha, copper K beta. Here is the peaks. Then if energy is greater than EK transition, then material can absorb. Okay, that's why nickel filter is used to absorb the K beta, filter out the K beta. So let's see the next question. Which of the following statement is true about the characteristic K radiation peak in X-ray radiation? Which of the following statement are true? So what is the order of the wavelength? Let me give to you hint. Let's say K L M N. A transition from this is K alpha, K beta, K gamma. And also alpha 1, alpha 2 is a sublevel of the cells from the L cell. Let's say L1, L2, L3. So please choose the right option according to the wavelength. Let me give one more hint. If let's say this band gap is 1.54, let's say, assume in electron volt, and this will be high, obviously, from here to here. So which one, lambda equal to hc equal to hc by lambda? You can use this relation. Lambda is inversely proportional to the energy. Now try to solve this question. Check yourself. So answer, check now. Your answer is correct. C will be the answer. First is wavelength is K alpha 2 in wavelength. Energy by just reverse K alpha 1 and then K alpha beta. K beta. So C is K alpha 1 is from the higher L1, L2, L3. Then K alpha 2, use this equation you can use. So if the K alpha is minimum, band gap is look like is minimum, then just reverse in the case of the wavelength. So that's why K alpha 2 will be higher than the K alpha 1. Clear here? And K beta from air to L M cell to K cell transition. The energy of the K alpha 2. So let's say K alpha 2 will be higher energy of K alpha 1. Sorry, I'm wrong there. 1 minute. From the picture, you can see energy of K alpha 2 is less than energy of K alpha 1, energy of K alpha beta. If the band gap is higher, then energy will be higher. You know, then the energy is inversely proportional to the lambda 1 upon lambda. So order will be reverse. K alpha will be higher than K alpha 1, then K lambda beta. Clear? And in this picture, short wavelength, we can calculate from this formula hc by p lambda, lambda minimum we can get. When we accelerate the electron from the source like 10 kV, 15 kV, 20 kV, 30 kV, from 0 to up to a certain voltage, we will not get the characteristic. Only we will get the continuous. In a particular voltage, we will get the characteristic alpha beta radiation only. Okay. So which of the following X-ray radiation most studied to characterize a iron content material? See, these are the option and give me the answer. So answer will be C. Check your answer, and D also. You can see in picture cobalt and chromium as the wavelength of the characteristics 1.79 and 2.29, while the iron Fe 1.94. So we can use nearest material that can get the X-ray. Next question, which of the following is are true for the rotating crystal methods? These are the option. Wavelength of the X-ray is fixed, diffraction angle is fixed, wavelength of the X-ray is in a range, diffraction angle is variable. This is a particular type of the methods that we can measure the X-ray diffraction by rotating crystal methods. Here we can rotate the crystal, while X-ray can be fixed or variable, diffraction can be angle can be fixed or variable. Which option you please give me the your choice. Then we will discuss. So let's see the answer. Wavelength of the X-ray is fixed and diffraction angle is variable. See in the slides screenshot single crystal variable X wavelength, but for the rotating crystal fixed wavelength and diffraction angle is variable. Only theta is variable here. So which of the following method can be used to determine the single crystal structure of single crystal? Love method, rotating crystal methods, powder methods, and Devasser methods. Crystal structure for single crystal. As we seen previous, rotating crystal is the one of, and second is the lava method also. So see the next question. This is numerical. The source wavelength limit SWL in an angstrom for the 15 kV X-ray tube voltage is, you can use the Planck constant 6.6 10 to the power minus 34. This is minus 34 joule second, sorry. Speed of light 3 into 10 to the power 8 meter per second. 3 into 10 to the power 8 meter per second. Electronic charge equal to 1.6 into 10 to the power minus 19 coulomb. So these are the options. Please calculate. You can use equal to, let me hc by lambda. You can assume energy in a potential energy which is provided by the potential difference, which is 15 kV kiloton volt. This value is 1240. If lambda then 9 angstrom, you can put energy. So please try to solve this question. use this concept, you can take 5 minutes for this question. Yes, sir. I have show you. Let me show you 1 minute. The exact formula that you can use. Yeah, Hc by lambda, the energy in electron volt. So you can apply directly voltage volts in nanometer. Now in angstrom is electron volt. Put in electron volt. So I have used E for calculation purposes here. So the final is in volts, voltage in volts. Then lambda will be in angstrom. You can take 2 minutes now, put the value and give me the answer. Did you get your answer? So lambda will be kV. V equal to, you have kilovolt or 15 into 10 to the power 3 volt. Now this will be in angstrom. Solve this equation. So answer will be, this is around 26 in angstrom. So C will be the answer. Yes, we are correct. So use this formula to calculate. Okay, you can see that we have used formula. So next question, the interplanar spacing A between the 110 plane of the cubic lattice with the lattice parameter 3.9 angstrom is. You have to calculate A for the 110 plane of the cubic lattice, the lattice parameter. So sorry, you have to calculate D. 2d sine theta equal to m lambda. This is the one equation. And second will be this d equal to a by h square k square l square. Use these two equations, first and second. We will get, you have to find out the just d, interspacing distance. So use only, let me show you 1 minute. Answer will be a, but how? Let's see. This is the equation. A is already given in angstrom, and HKL equal to 110 is given. Use these in this first equation. D will be, so 3.9, 1 plus 1 plus 0 whole square is also 1. 3.9 in angstrom. This is divided by root 2. Please calculate this. Tell me the answer now. Yeah, this will be 2.758 in angstrom. D nearly 2.76 in angstrom. Clear to you? See the next question. The X-ray beam of the wavelength 1.54 angstrom, this is copper K alpha, is incident on the FCC percentage cubic crystal of the lattice parameter 2.8. What will be the closest value of peak angle, Bragg angle in the degree, the second order 110 reflection? These are the options. Please solve. Use 2d sine theta equal to n lambda and d equal to, this is second. Use first and second, and other things are given here. We have to calculate Bragg angle. You can take 5 minutes for this question, but solve. Okay, so let me show you the answer. Here we can calculate according to the n equal to 2, HKL are given, theta and A are given. So answer will be C. Please check the calculation. Okay. See. Okay, nearest angle is 51. Pick out the correct statement about the XRD, X-ray diffraction. Diffraction occur in a specific direction along which the constructive interference occur. X-ray can easily penetrate the metal because they have longer wavelength. Modern X-ray diffraction uses scintillated or CCD detector to record the angle and intensity of the diffraction beam. K beta radiation has a low energy but high intensity in the compared to K alpha. So choose your option. Let's see the answer is interference, constructive interference when we get XRD. Modern X-ray, CCD, and record the angle and intensity are used. So this formula we have already seen, but we can arrange these square the 2d sin theta equal to n lambda and second, then we will get this equation. So we will use this equation in the upcoming session. For the BCC crystal A equal to 2.87 angstrom, find the D. What is 100 cubic you have given? You have to find interplanar distance for D equal to, sorry, plane is 110. Here you can use n equal to, if not given, n equal to 1 first order diffraction order. Now please solve this question. Give me the right, choose your right option according to the your option answer. Then we will discuss. Let's see the answer. Answer will be C. Oh, both are same. So answer B and C also the same option. This is sauce. Yeah, this is correct answer. Just simple calculation. Next question. For a cubic crystal, lattice parameter equal to 4 angstrom. What is the D spacing? D. Please give me the your answer. Let me wait for your response for 2 minutes. Use this equation. H. Mhm. Use this given parameter in this equation and tell me the answer. Okay. Again is a option mistake. So let me check. Okay, C. Also B is correct. 2.31. So let's come to the next concept. Lattice identification of the Davis lattice. We know the Davis lattice. So primitive, body centered and face centered. For primitive, these h square, k square, and l square value is proportional to 1, 2, 3, 4, 5, 6, 7. All are so the all HKR reflection are present in body centered. Some of these HKL should be even. Only this present. Face centered HKR unmixed. All are even or all are odd. Unmixed. Okay. So we will solve the question on base that. So first question. Please give me your response. In a simple cubic structure, which reflection are allowed? Only even, only odd, all edge scale, or none of above. So all should be present as we see. In a body-centered cubic, BCC structure reflection occur only when next question. In a body-centered cubic, so A is the correct option. See the next question. In a FCC, reflection occur only when these are the options. Please choose the right option. Okay, HKL are odd or all are even, as we see. So let's see the next question. First strongest XRDP in the abscisic structure like NaCl, aluminum or coke, Cu, corresponding to which plane? Now tell me the answer. Let me give you a hint as we discussed. S centered first will be proportional to HKL square will be 3. Now you can think about that. So H square K square L square is proportional to 3. Then we can think about 3. Okay, so C will be the answer. We have discussed 29 and 30 all the same question. Sorry. Ah, a question is that a cubic crystal given XR duplicate sine square ratio of 1 is to 2 is to 3. Which of the structure is most likely? Simple cubic, BCC, FCC, hexagonal. This is the question. Sine square. You know, first is 2t sine theta equal to n lambda and d equal to ay for the cubic systems. Let square all this 4d square sine square n square lambda square and you can d square sorry square should whole square should be get out 1 minute. You can put the d square value here, then 4 a square divided by h square k square l square and lambda square and n also square. So and sin theta also. If we a is lattice constant, lambda is fixed, a is fixed, then sin square theta directly proportional to h square k square l square. Okay, now I have given sin square theta ratio 1 is to 2 is to 3. 1, 2, 3. For theta 1, theta 2, theta 3. So as we discuss, you can put if all are things, all HKR are allowed 100, you have to check 110, 111 like that and put and check This is 1 first. Give you HKL square 1, 2, this 3. And if all HKL are allowed, then this is known as simple cubic. You know the reflection allow fraction for the HKL is 1 is to 2 is to 3. Now, cubic crystal system sin square 2468. Which crystal system? Simple cubic, BCC, FCC, hexagonal. You know, in simple cubic, all are allowed. That's why this is not will be the answer. You have to check all three is BCC, FCC, and hexagonal. 2468. 2110 H square K square L square 4220. Sorry, this will be 6 8. What will be that? This is 112. This is 4. This is 6. Then yes, please tell me the plane which give H K L square is equal to 8. Okay. So answer will be HKR even then BCC. You know some of these two. This is some two. This is some two. This is 6. 6. Okay, like that. So you will get the right answer. Next question. The cubic crystal system. So the P sin squared is ratio 3 is to 4 is to 8 is to. Which crystal is it? Simple cubic, BCC, face centered, and tetragonal. If question asked like that, please find the planes corresponding to this HKL. Question can also like ask like that. So be careful. Learn the concept. Question can ask any type. Can be turned into complex. But concept always apply. So learn the basic things. You will definitely get the answer. We have did a mistake here. This is node 6. Sorry. We have 6. 2 square is 4. Then 5. Then 6. Should not be used the commas. Then sum of these is also even. This is even. This is 2 to 0. So you have to also find out the planes and apply the condition. So answer will be FCC 3, 4, 8 and 11. These are the planes will be. So we have discussed question on base that structure, condition and material also. Simple cubic, polonium, body center, Fe, alpha iron, W or chromium, copper, aluminum, NaCl, FCC. Example. First peak is lowest HKLE square is 100. Okay, next question. The metal shows the XRD 2 theta. This is lambda is been it is known as to be cubic. What is the structure fit best? 2 theta is given, lambda is given. First peak is given at 2 theta equal to 44.7. So which type of cubic? Simple cubic, body centered cubic, hexagon, face centered cubic. Which structure should to be best? How you determine that? Think about it as we discussed so far. Give me the answer. You can take 2 minutes. So answer will be BCC. Epi give 100 peak around 8 to theta equal to 44.7. Okay. Next question. D equal to is given to angstrom lambda is given. What is the maximum diffraction order n can observe? Next question. You have to find out the maximum diffraction order n. Maximum. 1, 2, 4, 3. You can take 2 minutes also for this question. Try to solve. Then I will discuss. Yes, please answer. So answer will be 2. You know the 2d sin theta equal to n lambda, and we have to maximize n. So n will be maximum when if lambda is fixed, d is fixed, theta will be maximum, then n will be maximum. So maximum theta will be sine theta will be give you only 1. So 2d greater than or equal to n lambda, we can apply equal. So 2d by lambda, you can put the value here as we put, you will get 2. Maximum value of sine theta will be 1. Clear? In a XRD pattern, a peak appear at 2 theta 44 for lambda. If lattice constant are given, which plane does this corresponding to? We have to find the planes. You can take 2 minutes for this question also. Please now try to solve this question. I'm waiting for your response. So answer will be B. You have given calculation is given that theta equal to, if we, this is 2 theta 44 degree, so theta will be 22. Use 2d equal to n, 2d sine theta equal to n lambda, and if it's not given, and you can take 1 2D sin theta is given 22 degree. Lambda is also given, but you have to give an A, BCC, FE. So D equal to A. Use this to A by okay. You will get here after putting the value root square HKL is 2. Now you can suppose the value HKL would which sum is root 2. So only the B option. Okay. Next question. This is based on the Serre equation. Crystalline size peak broadening magnitude is given by D equal to K lambda beta cos theta, and you have a lambda equal to 1.5. FWHM beta is also given 0.01 radian in 2 theta is so theta is 20 degree, K is zero point 0.9. Find the crystalline size T. Please calculate the D. You have given the formula. Take 1-2 minutes for this question. You have to calculate D. K is given. Let me put lambda is given in angstrom. Beta also given in radian. Okay. Sine theta 20. Sorry, cos. We have to put cos. Calculate this value. You will get the answer. Answer will be B. Okay. Next question. If the stand cause point 0.02 shift in the diffraction peak at 2 theta equal to 30 degree, what is the percentage change in the D spacing? Now please calculate this. Peak shift with the lattice strand. Think about that. So as we know, the answer will be B. Relative error you can calculate from d theta change in 2d sin theta equal to n lambda. Okay, we have to apply the partial derivative in the d. Use this like that n lambda upon sin theta. Okay, and check out this. This is the relative error, and error is in the theta is given 0.01. So you have to calculate in radian as we calculated here, and you have to calculate the theta is 15 for cot theta. So percentage change in the theta will be you will get 0.65. So we can refine option if we needed. So what is this? We will get 0.6 which is closer to B. Okay, so let's solve the other type of question if not a 90-degree proportional to, or how we can get. So see this, we have using this equation, we will get the A. First, if you given the theta, calculate the theta and sine square theta, divide by minimum sine theta value. This is the minimum. So when we divide this, we will get 1 corresponding this value, and you have to multiply so that we get the nearest integer like 3, 4, 8, 10, 11, like that, which is according to this equation is h square k l square l square proportional to. So we can also say this is the this plane and this plane, and this is the calculated lattice parameter. Okay, so you can use this method also to identify the planes structure. Also, we can also use other method like that. If we have used second type, theta is given if the sine square we have to calculate. Now we have to divide 2, 3, 4, 5, 6, 7, and choose the common common parameter, and which is smallest as we mark here. So this is will A according to this equation, and here also we have used this, we will get again, we have to divide by common. This is not the completed solution is will be there. We could divide by the, this is common A, divide by A sine square, will get the nearest integer and HCl plane. So this is the question for you. Please note that and calculate these parameters. Please note, this is homework for you. This question, you can take the, okay, taking, this is the solution you will get. This simple cubic. Try to solve it. This is the second type. The theta is given. You can take the screenshot and please try to solve as I show you. I have calculated and you will get, this is also simple cubic. So this is the exercise for you. So all about this today. We have discussed basically polymer and XRD. So if you have any doubt, you can ask. Otherwise, we will end the meeting and we'll meet on the next Monday with that assignment. Thanks to all of you. If you don't have a doubt, let me close the session. We will meet on the next Monday. Okay, let me close if you don't have any doubts.